Now we are going to memory organization. How the memory is organized. This is important to you because you are going to store data and program everything inside that single chip. Where your programs are stored, data are stored, you should know them. Right. Program memory organization. PIC16F877A devices have 13-bit program counter capable of addressing 8K words of 14-bit program memory space. 16F877A devices have 8K words into 14 bits of flash program memory, while PIC16F873A 74A devices have 4K words of 14 bits. Addressing a location above the physically implemented address will cause the wraparound. You have access to only 8K of 14-bit words, but you are trying more than address more than that means automatically wraparound will happen. It will come to the beginning of your microcontroller. The reset vector is at 00 and interrupt vector is at 04. I told no. Whenever the interrupt happened, program counter is loaded with 004. Whenever I create a reset, I use a MCLR low input to microcontroller using pin 1. In that time, program counter will come to the beginning of the program. The 0 will be loaded to the program counter. See, the program counter is somewhat intelligent. If you load the address to it, it will simply execute the instruction in that address. Got it now? So, resetting or loading program counter to an address means we are forcing microcontroller to execute the instruction from that address. That is what it means. Do you understand that now? Do you understand that or not? See here, say reset vector is 000x, interrupt vector is 0004. What it means actually? Because reset vector is 000h, interrupt vector is 0004h. That is what written in this document. What it really means?
Mostly program counter will load this, will go to this location.
Program counter is loaded with memory location, you mean to say?
Yes, sir.
When program counter is loaded with 0, when program counter is loaded with 4?
So whenever the interrupt occurs, then it will be loaded with 004h.
Whenever there is an interrupt, it will loaded with 004. What is mean by interrupt? I believe we had a very long lengthy discussion. Interrupt means a disruption that can happen by means of different ways, using hardware signal or timer expiration, serial port reception. Different means the interrupt can happen. When the interrupt happens, program counter with 004. Okay. When the interrupt happens, program counter is loaded with 004. If a program counter is loaded with 004, what is going to happen? Program counter is going to have that value. That's all. No. Why it becomes a popular then? Why they have to load program counter with 4? What you told is when there is an interrupt, program counter with loaded with 4. When the program counter register is loaded with 4, what is going to happen?
It will execute the interrupt interrupt service routine.
Interrupt service routine is in which memory address? You should know. Okay, interrupt occurred. So program counter should execute the interrupt service routine, which is written in which address? Is it written at address 4? When you load any address to program counter, it will actually program counter is pointing the program memory. It won't point the data memory. That you all have to understand. When you load some address to program counter, immediately it will go and search, is there any instruction in that particular memory location? When I load 4, it will go and search for any instruction that we have in the memory address 4. If I load that with 0, it will go and search for any instruction available in the memory location 0. Memory location 0 means very first memory location in program memory. So you are rebooting your program. Okay. If it is an interrupts, it will come and search for memory location 004, whether it finds any function interrupt service routine to execute, because it is only one address right now. Immediately in that memory location 4, we can store 114 bits, 114-bit instruction right now. So can we write the entire interrupt service routine in one instruction? See, if there is an interrupt happen, program counter is loaded with 4. Program counter comes and check whether in the memory location 4 any service routine is there. It is only one memory location. In that memory location, can we write an entire service routine? No, you cannot. So then what will be there in memory location 4? Memory location 4 will have the gateway. Gateway means branching to interrupt service routine.
Yes, sir.
Got it now?
Yes, sir.
Whenever there is an interrupt, it will come to the memory location 4. There it will find a branch to routine. So it will go there. In that interrupt service routine, we have 2 steps: main interrupt service routine, sub interrupt service routine. In 004, they will branch to main interrupt service routine. In main interrupt service routine, they will check whether which interrupt happened. That can be a big program, that because anyhow that is in a different memory location. So there they can write that program. So which interrupt happened? If a particular interrupt happened, they will branch to that particular interrupt service routine. That is a child interrupt service routine. So the interrupts are handled in this way. If we don't have proper branching in the memory location 4 to correct interrupt service routine, if there is an interrupt happen, microcontroller will malfunction, because it will come and will load. For example, it initially you started the microcontroller, it started executing instruction from 0, 1, 2, 3, 4, 5. It is in the memory location 10. At that point, there is an interrupt happened. As interrupt happened, program counter is loaded with 4, but you have not handled the interrupt service routine effectively in memory location 4. So they will load the next memory location 005. When they load 005, whatever instruction which is there, that will be executed. Every time the interrupt happens, it will do a malfunction. So you have to handle your interrupt properly. Only then you can get a fruitful result. If you don't handle the proper interrupt properly, there is no point of having an interrupt at all. Do you understand that point or not, both of you, Amir and Vikas? Understood now?
Yes,
Now
sir.
the question to Amir. Whatever that I told is for interrupt service routine that we discussed. Whenever there is an interrupt happen, this flow will happen. If reset happen, I go and press the reset button, or I supply an active low to the microcontroller pin 1, but the microcontroller is waiting in infinite loop, as we discussed here. Right, it is waiting in this infinite loop. Moment the reset happened, what happened? Program counter loaded with 4 was loaded with 0. 0 means what? It's the starting of the program.
Yeah,
It
will begin from the start.
Brilliant. It will reboot. It will execute the program from the beginning. That's why whenever we press the reset button, whatever the flag toggling or analog to digital conversion or displaying some text, that will happen again. Do you understand now how computer works, how it reacts to interrupts and resets? Come on.
Yes, sir. Sorry.
Yes, sir.
So that is what they are trying to explain here. Right.